this part here, I'm going to explain on Maxpan Slab, how it operates. Design it in such a way that it is, we call it a one-way slab. It transfers loading into one direction. So when we are designing, we usually see what we call a panel, the direction of which you want to transfer the loading. Then you see what one is the critical beam. For example, here we have a cantilever. This cantilever is around 2.5 meters from here up to there. And when we are designing, the critical beam, this beam which is coming from that column, we have another support column here. You can see that column. We have another support column here. We have no column there. So the bars are running from that area up to now. Because this span is a bit wide, the bars which we put here, these longitudinal bars, must be stronger than the bars that we are putting here, which are running along this vertical part of the panel. Now, these are the columns. This is what we focus on design. So structure, when you're designing, that's why here you can see, for us to carry using that span, which was in the drawing, to carry this span here of 2.5 meters on this distance. Because we have a classroom down, we have to make sure we design bars that can carry all the loads that are transferred to it. You can see the direction of these Maxpans here. They are all loading to this beam. They are again loading to the other beam. You can see. Now, when you press the Maxpan this direction, it means that it's going to transfer loadings halfway to that, then halfway to the other beam. Meaning that this is a critical beam. Now you can see in our designs, the bars are fast. Carry this T25. We call them TMX, the one which is now recommended. We have two TMT and TMX. But this one is TMX T25. What it means that it has a diameter. This bar is 25 millimeters. Factory made and placed. These are the parts that passed. We had 1, 2, 3, 4, top and bottom. For us to have this cantilever. Now, because this is because we had enough bars here, we still had two options. One person will design a solid slab here. It's so much exposed to water, but because Apple discovered, we opted to do some on the coast and we made with the Maxpan Slab. But what we changed was not straying this material beam. We changed the flow of Maxpans. You can see here, these Maxpans we are loading towards here, but when the company and we did analysis, the Maxpans, we changed them and they loaded horizontally. Now they loaded to these bars here and also these bars here. So implying that on this section, the cantilever was loading between these two, which these two bars were being carried by these strong bars. And in our calculation analysis, it was possible. Anyone will have his own option. Someone will go with a solid, another one will go with loading this direction and includes beams. What matters is the target of the structural engineer, what is targeting on the cost wise. Because the client was okay with buying Maxpans and the little bars here. That's why here we used you can see here inside our ribs, we used 4 T row. You can see 1, 2, 3, 4. Meaning that every rib you see here was having 4 bars. Which these 4 bars would help carry the cantilever per rib. Now, when you check here, which is different here, in this bay, where we changed and we used this vertical way of loading Maxpans, we used only 2 ribs here. Remember, when you create a rib, it acts as a smaller beam that carries this Maxpan. That's what we call port 1, port 2, port 3, then also at the end. So at this direction we use 2, but when we turn this, we use 4, so that we can use the value that can deliver and we meet the purpose of what the client wants. You can see 1, 2, 3, 4. That's how we position and we do analysis when we are carrying out design. So it changes with the purpose with every structure you get when we are taking or trying to design like a panel like this. And we shall be always seeing on different projects how we consider it. But usually for us as a company, what we consider number one, their materials, the quality. Number two, the costs. Whatever you design, people over design sometimes, make sure it can reduce the client's amount of money don't spend on materials. Number three, it's sustainability. Can what you have designed sustain and meet its purpose? Because we have not had any problem when a project is designed and we find there's any failure. Because you know when you're designing here, you're seeing on deflection, you're seeing on squashing of columns, you're seeing on different shear failures. When you put all those into consideration, the structure is really stable to meet the purpose. So that's how we considered when we are designing this one cantilever of 2.5 vis-a-vis another cantilever, another panel which was the largest panel around 6 meters.